Hi everyone, I hope you are doing well. So this video is going to be a screencast solution of today's problem of the day for Geeks. And the problem name is better string, and after a very long time we have got a hard question. So I'm actually very excited to see what the problem is. So let's just quickly start with the description. It says that we have been given a pair of strings of equal lengths. Okay, so we want to find the better string. Better string is the string having more number of distinct subsequences. The length is equal. Hmm. Of equal length. Okay. So I believe that's why people say that they don't like lead code and geeks for geeks hard much. So the thing is, this problem of finding the distinct subsequences is a very well known problem. And if I'm not wrong, I believe I know how to solve this problem. Actually, distinct subsequences finding is a very well known DP problem, but it is not very difficult to understand. But if you have not studied it and you are thinking about it for the very first time, then yeah, you might find it a little bit difficult. So anyways, let us just discuss what I know about this distinct subsequences, and then we'll try to solve the problem with that particular method, right? So the very first thing is, let's say we just have a single character A, right? So what are the number of distinct subsequences you can form with this A? The answer is going to be 1, right? It is very obvious that there is only a single character. Now let me try to say the same thing in a little different manner. Let's say I have an empty subsequence, right? And then before it, remember I'm saying before it, I have a character A1, right? So what are the number of distinct subsequences? The importance of before it is that I cannot write empty subsequence and then A1, but I can write A1 and then empty subsequence, right? So you have to remember this thing. So A1 comes before this empty subsequence. Now if I want to find the number of non-empty, obviously non-empty subsequences, I can attach this A1 to this empty subsequence and the resulting subsequence will be A1, right? So this is what I was trying to denote. The idea is the same, the answer is the same, but the way of understanding the problem is a little bit different now, right? So I know I will initially have an empty subsequence, and if I have a character A1, then I can attach it before the empty subsequence. So now let's say I have a character B1. What can I do with this character B1? I can attach this B1 either to A1 or to this empty subsequence, right? So in this case, I'll have two options. One option is write B1 and then the other option is B1 A1, right? So you see, right, what I'm trying to do is I'm trying to attach it to the characters after it, right? Since it is going to be a subsequence, I'm not limited to the just adjacent character. I can take any character after it, right? So this is how I'm being able to form the subsequences. Now let's say there is a third character C1, right? So now with C1 what I can do is I can attach it with the empty subsequence, so that will be C1 itself. I can attach it with A1, so that is going to be C1 A1, right? And then I can attach it to B1, right? Then it is going to be, right, you see from B1 we have two options, again from B1 we had two options. So if I attach C1 to B1, right, if I attach C1 to B1 right here, you will see I will have two options again, that is going to be C1 B1 and then C1 B1 E1, right? So you see automatically all the other things are being figured out. I just have to worry about what are the characters that I can attach the current character to, right? So you see in this case I was trying to attach C1 to B1, so from B1 again there are two possibilities, so I have to write both of them, right? Now you might be wondering, if I am attaching to all the characters, then what is the difference? So the difference is, let's say I have B2 here, right? So can I attach B2 to C1? Yes, that is possible. So whenever I attach B2 to C1, it is going to get attached to all of this, right? It is going to get attached to all of this. So C1 will be one time written alone, the next time it will be written as B2 C1, then C1 A1 is done, then B2 C1 A1, right? This is how it is going to keep on going. Now can I attach this B2 to this B1? Yes, definitely yes, because I can attach B2 in front of this one, right? And then the next few characters will be B2 B1 and then B2 D1 A1, right? Now can I attach this B2 to this particular A1? The answer is strictly no. The reason being, if I attach this B2 to this A1, then I will get B2 A1, right? But you see B1 A1 is already done. Now this B2 and B1 is actually equals to B2. These are the same characters. I have just numbered them, so it is easier for us to differentiate between them, right? B is the same character, but they're just numbered different for us to recognize them, right? So B2 A1 is not distinct because B1 A1 is already counted, right? That means I cannot attach this B2 to this particular A1. Similarly, I cannot attach this B2 to this empty character as well, right? Because B1 here is already completed and I cannot write B2 alone, right? Because these two B's are essentially the same characters, right? So basically what we learned was we can attach any character to all the characters till we have encountered the same character itself, because after it will be just a repetition, right? So if we like just try to formulate it, then dp of I is going to be dp of I plus 1 plus dp of I plus 2 plus dp of I plus 3, and let's say we are going till uh, dp of j, dp of j. So j is going to be the last position where we encountered the same character, where we had same character, right? So this is that we have. So this is the whole definition of this problem, right? I hope that this was easier to understand. Uh, so I don't think that I've missed anything. I've covered all the things required in this problem. Uh, yeah, that I believe that's it. And we can use several methods to store all of these kinds of information, right? So if you are having a DP array, we'll also need a sum array, which is going to store the suffix sum obviously. So the suffix sum, because we need the sum from here to this particular point, right? That is why we'll need to have a suffix sum array. But since the number is very small, even if we don't have it, it is still going to work. We can just maintain a simple for loop and then do all the summations. But if you want to do it in this particular time complexity, then definitely we need to have that particular suffix sum array, right? The only reason of the suffix sum array is that we can calculate this particular answer in O of 1, right? Otherwise it will take us O of n time and the overall time complexity will be O of n square if we do not maintain a suffix sum array. If we maintain a suffix sum array, then it is going to be O of n only, right? So this was the whole idea about this problem. Now let us just try to solve this problem with the same idea. I hope that I was not wrong and this whole explanation will not go to waste. And let's just see str1 dot size, right? And vector int, let's say we have dp n plus 1 and 1, and then we have sum n plus 1 0, right? So you see, why do I have initialized this dp array with 1? So the last value, the empty subsequence value, should be equals to 1, right? So whenever I am calculating the answer for this particular a1, right, it is going to be the number of ways I can reach this particular destination, right? Then only I can attach it in front of this particular empty substring. So for empty substring I have one ways, then as soon as I attach a1 to empty substring, the total number of ways starting from a1 is going to be 1, right? So that is why it is like n plus 1, and then for summation obviously it is going to be 0. Now I'm just going to maintain a for loop. I is starting from, or let's say we can also create dp1 and dp. So from now on there are two methods. Either we can have two for loops or we can have two different arrays for the string 1 and string 2 separately. Let's just make two for loops to make it simple, and I'm going to start from m minus 1. Since the length of the string is same, we can use reutilize the same dp and sum array, right? And we also need a last position array, right, to store the last positions. So last is going to be 26 and minus 1, right? So now dp of I is going to be dp of I plus 1, right? If last of s of I minus a is not equals to minus 1, that means this character has been encountered before. In that particular condition, let me store it in somewhere. Last is equals to s of I minus a, right? So if post is not equals to minus 1, then dp minus is equals to dp of post plus 1, right? So this is what I am going to do, and I believe this should work. Now int, let's say a is equals to accumulate dp dot begin dp dot end minus 1, right? So you see what I'm trying to do here is, uh, let's say for each of the characters in the dp array, we are calculating dp of I. dp of I is denoting, let me just write it. So dp of I is denoting, it is going to denote the number of subsequences starting from position I, right? This is what dp of I denotes. Now to find all the subsequences, distinct subsequences, I have to make the summation of all dp of I, right? Starting from position 0, 1, 2, 3, 4 and so on. But you see, we created the size of n plus 1 and initialize the nth position by 1, right? So we do not require this one. That is why I am just adding minus 1 to it, right? This accumulate function will just sum all the values, and this minus 1 will be just will be subtracted from the total sum, right? This is the initial value for the sum, right? So this is what we do, and I just stored it somewhere. Now again, there's one more thing that we needed to do, that is last of s of I minus a should be updated, right? So it is going to be I, and for all other things, and so this should actually be sum of I plus 1, sum of I plus 1, similarly sum of post plus 1, and sum of I is equals to sum of I plus 1 plus में dp of I, right? So I actually wrote it wrong. They should all be sum, and I believe that is correct now. So what we can do is, we can reinitialize sum of n with 0, and we can fill last dot begin last dot end with minus 1, and do we need to change the TP array? No, I don't think so. Right, sum of n will also be equals to 0 only. We also will not need to change this. So I'm just going to make a second for loop. I is equals to n minus 1, I is greater than minus 1, I minus minus. dp of I is going to be equal to sum of I plus 1, and then again I'm just going to calculate the post of, so you see that this should be str1, and here also str1, and other places no. So we have last of str2 of I minus a, right? Now that we have got the position, if position is not equals to minus 1, then I am going to do dp of I minus is equals to sum of position plus 1, right? Now I am going to update my last string 2 of I minus a is going to be equals to I, and sum of I is going to be equals to sum of I plus 1 plus dp of I. So there is one more thing, that since we are already calculating the sum in the summation vector, then we can also do sum of 0, right? So yeah, so this is correct. I believe it should be correct. So sum of 0 here also. Now the reason why we are not subtracting this minus 1 in this case is because in the summation vector we never took that one, but in the dp vector we took that one. So instead of summing dp here, you can also sum the summation vector itself. So yeah, I believe this should be correct. I'm just going to return if A is greater than if A is greater than equals to B, then I'm going to return str1, otherwise str2. Right. So I believe this is correct. Let me just compile it. Okay, so I just want to print this A and B as well, just to check whether the subsequences that I'm getting is correct or not. So if I print this, according to them, GFG has 7 and GGG has 4. So okay, so we are getting 0 and 0. So that is the reason why I printed this. There must be some issue with our code. Yeah, so I will have to take this as one. There is nothing I can do. So why do I even need the DP array, right? DP array, is it storing something? Nope, it is not storing anything essential. So instead of having all of this, I can just have it like this, and then current also here, right? So we didn't actually need the DP array separately. We can just have a variable here, current, and current minus is equals to and current. So this is actually itself the DP array. Instead of storing just the values, we are storing the sum. Now since we are adding 1 to it, we also have to subtract 1 from here, right? So if you keep 1, then the only difference will be that it will also have an empty subsequence. Okay, yeah, so they are counting the empty subsequences as well. So let us just try to do it manually. What is the, if you have GGG, so one subsequence is G itself, then we have GG, then we have GGG, right? These are the only 3 subsequences that we can form, right? And if we also include the empty subsequence, it comes to 4, right? So that means our algorithm is working fine, and you can it's up to you. If you don't want to subtract, it's totally fine, because relatively if you subtract -1, if you subtract 1 from both, then the answer is not going to change, right? Because it is going to get subtracted from both. So it's up to you. But I was just telling you that if you also want to include the empty subsequence, then it is fine. If you don't want to include the empty subsequence, then you will have to add -1 here, right? So I believe this is correct. Let me just submit this and we'll see. So yeah, it passes all the test cases and the solution is absolutely correct. So you see that we have accepted, and yeah, that was it for this video. And the idea is not very difficult. Again, I'm telling you this. The idea for this problem is not difficult. It's just that the first time you are encounter it might seem a little overboard, but once you know and once you have solved this problem, then it will be much easier. So that was it for this video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you to keep solving new problems. So that was it for this video, and I believe I have already explained the problem before even writing the code, and that is the only reason for that was I had already seen similar problems. So let's just wrap it up for today, and I'll also try to post the lead code video. So stay tuned for that. Till then, keep coding, stay safe, bye bye.